everybody, get ready to do lesson 13.4 of Pre-Algebra Math, Part 1. And today we have a 38-point skill sheet for classwork and a 20-point notebook guide to do today. It's on translations, reflections and rotations. Here's the standard here, and here is a description of the objective standard. Today's bell work teachers, we have multiple choice up here. Find the value of x today, students, so find that value of x. And we have a stop sign. What is the measure of the interior angle of a stop sign? So what is a stop sign? It's an octagon. So students, give your students 6 minutes to do this. Okay, welcome back for solutions to our bell work. Here is the solutions here for number 1, 135 degrees. Here is the formula for finding an interior angle of a polygon. So the correct response would be H. It'd be great if you have this work. Students, if you don't, you should copy this down and include it with your classwork sheet. And then for number 2, you would find out these are corresponding angles here. So you know this has to equal that, so just create an equation here and solve for x, and x would equal 8. Into our lesson today, you plotted points in the coordinate plane. You'll translate figures in a coordinate plane. Snow tubing. Inflated tube, you'll see you can use translation to describe a change in the position of a person sliding down a hill. And here are some definitions of transformation. This is classwork page 1, students, is a change made to the location or to the size of a figure. The new figure formed by a transformation is called an image. In this book, in this course, the original figure is blue, the image is red. Prime notation is used to identify the image of point A. You read A, I guess, what is that, A tick mark as A prime. This would be called A prime here. So a translation is a transformation in which each point of a figure moves the same distance in the same direction. In a translation, a figure and its image are congruent. So it's a congruent figure that just moves. Okay, a transformation and an image, students, in your own words. Define this. When I teach this class in a classroom, I check my notebook entries by students on Fridays. Teachers, that's up to you. But this is worth 10 points, so it's worth quite a bit, students, to define these terms. And translation and tessellation. We haven't done tessellation yet, so hang on to that. But translation we just did, so define translation. Okay, into our first example here. So example 1, describing a translation. For the diagram shown, describe the translation in words. So what do? We're moving this way and then down this way, right? I mean, that's what it looks like to me. It's a tube. Somebody in a tube went like that. So you got somebody in a tube there. So what went on? Think of moving horizontally and vertically from a point on the original figure to the corresponding point on the new figure. So for instance, you move 200 feet to the right and 40 feet down. So 0, 100 to reach A prime, which is 260. That would be the situation there. Okay, so describe translation of words here. So we have a translation here, correct? We go from blue to red. Translate 4 units to the right. So we started here, and this goes to the right 4 units, and then down 3 units, 1, 2, 3. So that'd be a way to describe this translation in words. And then students, this is yours. You go from blue to red. This is E prime here, and this is your triangle prime over here. So you're moving from your blue to your red, like this. Okay, a coordinate notation. You can describe a translation of each point xy of a figure using coordinate notation. xy to x plus a, and then y plus b. That would be coordinate notation there, where a indicates how many units a point moves horizontally, and b indicates how many units some point moves vertically. I mean, y is the vertical, and then x is the horizontal. So what do we do with that? Well, move the point xy to the right if a is positive, and to the left is if a is negative. In this situation here is positive, so x is going to move to the right. So what do we do here? This moves to the right here. We have a line here, -1, 2, then -3, -1. This is point B and point A. So y minus 1. So we're going to go to the right 4 because of this, and then we're going to go down 1 would be the situation here. So this would be your translation here. This would be B prime, and then this would be A prime here. So it would be 3, 3, 1 here for this point, and then this A prime would be 1, -2. So it would be 4 to the right and make it 1 for this point here, and then it would go down 1, so it would be -1, 1, -2 here. That would be a translation. When this describes your movement, and this is the actual translation on a coordinate plane. So move the point up if b is positive and down negative. That's the idea. Translating the figures, so we have draw ABC of vertices 3, -4, 3, 0, and C 5, 2. So it look like this here. This will be this triangle here. Then find the, we got that, just in case. You should have a grid on your classwork sheet. In fact, I know you do. So sketch this in your grid, students. And then of the new image, after the translation, would be x minus 6, y plus 2. So what's this image going to look like when we move it here? -6, so it's going to go this way, and then up 2, right? So that would be the new image. Here's the new image here. This would be your triangle prime here. So we go over 6, and then we go up 2. That's why you have that point there, and like that, like that. See that? Okay. Move 6 plus 2. Yeah, we got it. Okay, into, do I have done with this? No. Let's see, draw triangle ABC, then to translate ABC, subtract 6 from the x coordinate and add 2 to the y coordinate. So we have 3, -4 will be the original, and then A prime would be 3, -3, -2. This will be a translation here of, so you subtract 6 from the x and 2 to the y. So we're subtracting 6 from the x, and move this way 6, and then this will be the new point here. So we go from 3, -4 to -3, -2. And then 3, 0, then our translation. Here's our original, then our B prime be -3, 2. So we're moving from 3 to -3, because we're moving, subtract 6. So we're moving to the left 6, and then up 2. And then 5, 2 was the original. Where's 5, 2? Here's 5, 2. And then we're moving that to -1, 4, which should be here. And yours should look, this was the original. This is the blue triangle. Then our red triangle should be here. So this would be the new plot of our translated triangle here. Okay. Draw a quadrilateral JKLM with vertices here. -5, 0, -2, 0, and 3, -4, and M, -2, -4. Then find the coordinates of the vertices of the image after this translation here. So you're adding 7 to x, and then you're adding 4 to y. Students, this is yours down here. Describe these translations here. Use it on a grid. There should be a grid on your classwork sheet for sure, so you can do this using a grid here. x plus 3 are described. This is a description here. Wait a minute. You're just describing here what happens with these two different translations. So it'll be a written response here, students, for this. Okay, let's do our guided practice. Here will be the translation here. So this will be our new quadrilateral here. We started here, and then we moved in this direction like this. With these situations here, we added 7 to x, so everything moves to the right 7, and then up 4 is what we get for our prime quadrilateral there. Here's the original, and then this is the image. So they call the prime quadrilateral the image. So this will be the image of that moved or translated. So that was 13.5, I believe. 13.4 part 1, 13.4 part 1, part 2 and part 3 available here, as well as worksheets, quizzes, tutoring, tests, solution PowerPoints, you name it. Thank you.